Hello everyone, welcome to Focal Point. And now we are going to take little complex but very good example of pointers. So here we are taking our standard input output header file. Now we are going to call our main function. So in main function we have simply taken an integer array, and this is how we are going to read this. So how the compiler read this line. So it will read from left and stops when a operand is found, this b is found. Okay, so now it understand that this array sign has the higher precedence than this asterisk operator. Okay, so this operator we have already we can refer the operator precedence table, where we can get what is the priority of different operators. So what compiler going to understand that b is a array. So what is b? B is a array of pointer. So what asterisk going to show at the declaration time? At the declaration time, asterisk means that this is a pointer. So b is a array of pointer to a integer. So what b going to do? B is a array of pointer, and that's why it will store the pointers of type integer, and that's why these a plus 3, a plus 2, a plus 1, because a is a array of integer type. Okay, and that's why it can store this b is a array of pointer, can store the addresses of integer type. Okay, so here we are going to store the addresses of our these integers, and c is and b is the address. B stores the address of these addresses, array of addresses. Okay, and that's why b contains the address of address. Okay, address of address array, and that's why double pointer is needed to store the address of it. So let's see what we are going to do in here, and what should be the output in these three lines. So we are going to print these three values, and we are going to change our values as well in between. Okay, so I have told you in here that our post increment has higher priority than our asterisk. Okay, so this is we can refer through our operator precedence table. So let's take array and array of pointer. So this is our integer array where 50, 20, 30, 10, 40 and 60 is stored. Okay, so assume that these are the address of it: 100, 0204, 100 and 600 and 810. So as we know that the size of an integer is 2 byte, and that's why 2 bytes are increased. And this b is a array of pointers, and that's why it is stored the address, and we know that the size of address is 8 bytes. And so assume that the address of this array is starting from 200. That means b will storing the 200, and it will increase by 8 because the size of address is 8 byte. Okay, and now we are going to store the address of b inside the c, and that's why c stored the value 200. Okay, so these are the assumed values. These addresses we have assumed to make our code understand in an easier way. Okay, so what now we are going to execute this line. So what is the meaning of this? So as we know from the precedence table that this post increment has the higher priority than our asterisk, but we also know that this post increment means that it will execute this code, it will increment the value of c after this line will be executed. Okay, so what is the meaning? At this time c is pointing to this first pointer. Okay, after increment it will point to the second pointer. Okay, so address will be changed to 202 to 208. Okay, but before that we need to it is saying that we need to go inside the c. So but we are not assigning it, we are not doing anything, so this value will be wasted in here. But this is what we are going to do. So asterisk c means we are accessing this first address, and we are not doing anything, and after that we are going to increase our pointer. So C pointer will be increased as this is a pointer, so it will increase by 8. So I have told you that increment will be based on what is the type of it. So the type of C is type address, and that's why it will increase the value by 8 byte. Okay, so it will change the value and it will point to this 208 pointer. Okay, and now we are going to print something. So this is C minus B. So what is the value of C? That is 208. Okay, C minus B. What is the value of B? B is stores the value 200. Okay, and now we are accessing our asterisk C. What is the meaning of asterisk C? We are pointing to this. Asterisk C mean 104. 104 minus A. What is the value of A? That is 100. Okay, so A stores the first address, and double asterisk C means it is pointing to this. Asterisk means 104, and 104 asterisk mean we are in here and accessing this 30. So 30 will be printed. So what is the finally printing value? So we are subtracting 208 minus 200. So these are the addresses of address, and that's why when we will be subtracting this, it prints the value when how many value are between this. So 208 minus 200 means it will store only one value. Okay, so only one address is in store in between. That's why it will print the value only one, because only one value is stored. Mean 208 minus 200 mean only one value. Okay, because this is the type of pointer. And 104 minus 100 means we are now talking about integer values. Okay, so 104 minus 100 because the length of 4 byte. I mean this is the difference of 4 byte, right? So in the difference of 4 byte, how many integer will be there? 2 integer will be there. And here in the length of 8 byte, how many pointers will be there? Only one pointer, and this is simply a 30 value. So what will be printed in here? 1, 2 and 30 should be printed. Okay, so let's write that out in here. 1, 2 and 30 should be printed. Okay, now this will be printed, so just remove that out. So these are the updated values. So now we will checking that this line. So what is being happening in here? We are accessing our C. Okay, so C value is 208. Okay, so 208 pointing to this, and asterisk C means we are in here, we are accessing this 104, and double plus this is pre-increment, not post increment. This pre-increment, that means we have to do increment right here. Okay, so as this is the pointer to an integer, and that's why it will when incrementing it will increased by 2 bytes. Okay, so 106 will be here. So we are going to do step by step thing. So we have incremented this. Now we are accessing with this asterisk, so 106. So now this is in here inside this. So asterisk 106 means we are accessing 10 now, and after that we are doing pre-increment, and that's why we are going to increment by 1 in here. Okay, so this is the procedure of executing this. So again we can see that this is our 208. Asterisk means we are inside this. Pre-increment, that means we are going to increment this, and increment of integer pointer, that means we have to increment it by 2 bytes, and after that we are accessing this 106. That means we are going accessing this 1010, and after that we are going to increment that. That's why we have incremented this value. Okay, so now we are going to print our next value. So what we are doing the same thing again. So again we are going to print C minus B, that is 200, and asterisk C, Now the asterisk C, that is the value inside 208, that is over 106, minus A, that is over 100, and we are accessing asterisk C, that means inside this, and value inside that, that is 11. Okay, so now how many address can be stored from 208 to 200? That is 1, because that is 8 bytes, and here this is 6 bytes. So how many integer value can be stored in 6 bytes? That is 3, and this value 11. So next value should be printed, that should be 1, 3 and 11. So let's note down that in here, 1, 3 and 11. Okay, so now let's execute the next line of code. So next line says that we need to access double asterisk C, that is 208 and 106. So now we are inside this, so we are accessing this 11, and now we are going to increment this with pre-increment increment. Okay, so it will increment to 12. Okay, so this is the value that is incremented to 12. Now we are doing again printf in the same thing. So 208 minus 200 and asterisk C, that is 106 minus 100, and now we are going to access double asterisk. That means we are accessing 12 in here, because 208 asterisk 106 and again asterisk, that is 106, that is 12. Okay, so again this value is 8 bytes, so one value 3 byte 6 byte, that is about 3 and 12. So 1, 3 and 12 should be printed in here. So 1, 3 and 12 should be printed in here. 1, 3 and 12 should be printed in here, and that's it. And after that this program is executed, so this whole value will be vanished. Okay, so this because we are calling in our main function, and that's why this whole value will be vanished after this line. Okay, so let's see what should be the output, complete output. These should be the output of it. So 1, 3, 30, 1, 3, 11 and 1, 3 and 12 should be printed. So let's run our code and try to see what is the output of it. So yeah, this is our output, 1, 2 and 30. So this is correct. 1, 3 and 11, that is correct, and 1, 3 and 12, this is also correct. Okay, so this is our output of the code. This is really good example where we need to analyze thoroughly. So we need to actually write the array of addresses, and then analyze what is going on line by line. We need to understand what is the priority of different operators. So for that we need to refer our operator precedence table. Okay, so because we are not using any parentheses in here, and that's why we need to have an idea about the precedence of the operators, and that's how we executed, and this is the output of it. Okay, so you can also try this code. This looks very simple, but often we can do a little mistake in here. So very slowly and line by line we need to execute to understand what is the output of it. So thank you so much. You can also try this code. We will see some other example in pointers. Thank you so much.